Hi everyone, this is Ants. Today I'm going to be showing you the performance comparison of Godot's and libGDX Jolt physics engine implementations. Godot in 4.4 included Jolt physics into its engine, and you could turn it on for 3D, and I did, and I'm going to compare it to the recently released Jolt physics engine for libGDX, which is a Java framework, game framework that's been around for quite a while, more than 12 years, I say. So I am going to test Windows and web performance, and the web performance results are very surprising. Anyways, well, I wasn't surprised, but anyways, let's get started. I have a PDF, and I'm not going to go through this. It's just going to be just too much of a bore. But I put in a lot of work to document everything, where I got everything, and what the setup is, and the thread details, all sorts of stuff. I'm not going to go through it because people are just going to skip out on the video. So basically, I got the results and I output it to the console, and I've included both web builds and Windows desktop builds. But the libGDX version has a jar file, which means it could run under any platform that supports Java. So you could test it on your other platforms too. But here are all the outputs, and again, I go through, but here are the results, right? So in terms of a Windows desktop, libGDX with 11 threads on my 12-thread Ryzen 5 performed on average 205 FPS. Its minimum was 191 and its maximum was 215. Keep a note on the maximum. And so libGDX came at 205, and Godot came in on an average of 342, but its maximum was 716. So this is an indication that it's not, I don't think it's Jolt that is the Jolt physics engine that's running through JNI is the problem. I think it's actually the JVM and the JNI interface that is the bottleneck. And some indications I got is when I change the threads from 11 to 10 to 9 and 8, it only goes down a few FPS each thread. And by the way, my runtime for libGDX, you could set the threads, how many threads you want, so you could actually test to see what's going on and increase the threads. So if you actually look at this, it's about 70%. It's 1 times 7 times faster. Okay, scratch that. It's 70% faster. Godot is 70% faster, which is significant. It's pretty significant. But on the web, it's libGDX is unmitigated disaster. And by the way, this 27.6 FPS, it's after my optimization. I did my best to optimize libGDX, and I documented my optimizations. I implemented physics ticks. I changed some of the bad setup. So the original test was from XPE's samples, and I cleaned it up. I didn't destroy any bodies. I reused body. Like I did so much stuff to improve the performance, and I got it. My original one was 11 FPS on his website, and I got it up to 27. So it's more than doubled. So what I'm trying to convey is I'm not here to actually make libGDX looks good. I was actually working hard for libGDX to perform better, and it still didn't perform better. Now, one of the things about this web is, you see the max, it's only 75, 76. My monitor is 75 hertz, so it can't get higher than 75. So what I'm trying to get at is this number is actually higher. If I had a 240 hertz monitor, you know, because on the web browser, it uses the VSync of your monitor, and that's the maximum frame rate, it's probably higher. Okay, so what I'm trying, so it's higher. So in summary, on Windows desktop, from my setup, Godot is 1.67 times faster, or 67% faster than libGDX. But on the web, Godot is at least 2.7 times faster. It's probably more than 3 and close to 4. And the reason why is Godot now in 4.5, and I'm using 4.5 beta 3, it has SIMD support by default on all web builds. And so Jolt takes advantage of SIMD tremendously. And with SIMD instructions, you can sometimes do 4 computations in 1 instruction. So you could do 4 times the work. And with physics and 3D and transformations and updating of vectors of angular momentum and gravity and forces and rotations and velocities and all kind of stuff, this is a big deal. And now on the web, Godot supports it. And this is the reason why Godot is blowing the pants off libGDX. Maybe they could compile, but I don't know what's going on, but it's pretty bad. So as of July 28th, it's pretty bad. And again, I need more people to kind of test this, but from what I've seen, it's actually pretty bad. So, and I have 2 videos here so that I could have proof. I run both web and desktop. And later on in the video, I'm going to show you how to run the test. There's multiple ways to run it. So some of the differences, as you can see, is for some reason, I copied all the values the same, and it's documented in this presentation that it's going to be a PDF. I've documented it, but libGDX just seems heavy. I think maybe the masks and the half extents, I don't think maybe it's done right, or maybe something on, but as you can see, the Godot seems more fluid and it's 666 max FPS versus 200 over here. But anyways, one of the things some people might say is, there's more collisions going on in libGDX. Yeah, maybe at the beginning, but as you can see is the max FPS is the indicator that it's not Jolt that's the problem. The max FPS coming in on Godot is 600 FPS. Meanwhile, the max on libGDX is 200. There's something else that is holding back libGDX from my analysis, right? So as you can see, I got all the data here, right? So this is kind of like proof of all the data here. Now I ran this with OBS, so these numbers are going to be slightly less than the numbers I put on the PDF because I didn't run OBS. OBS is a video capture software, and it takes some of the GPU and CPU bandwidth and all that kind of stuff. It's just slightly slower. It's not really that big of a deal. And here's the web. Look how bad the web is on libGDX. Like even the max is 29 FPS. Like something's, and they're falling. So when the boxes are falling, sometimes they kind of get disabled, or there's not much computations needed because they're not touching each other. So that whole argument where the libGDX is because it's heavier, it's numerically for like 3-4 seconds, it's falling. There's no collisions. So I don't know what's going on. It's just there's a bottleneck somewhere. There's a major bottleneck somewhere. Yeah. Anyways, so that ends the presentation of the results. And thank you for watching. But if you want to stay longer and get more information on how to run these tests, I'm going to be explaining it now in this next section. If you actually want to see your own results tested and you don't know how to run them and all that kind of stuff. As you can see here, you go into developer tools and you can get the console I'm showing there, and I'm going to be doing it on this side here. More tools, development tools, and go to the console, and you'll get the output onto the console. Okay. Yeah, so we're going to transition over to the setup of where to find the binaries, okay? So this project, where I'm going to link in the description, is a Gradle project. So it's basically a libGDX project, but I included both the libGDX and the Godot exports. What I mean is the binaries, basically, right? And I also included the HTML builds, and I also included a Python 3 server so that you could run it, but you could also run it, the web versions from IntelliJ. Now, if you don't want to install IntelliJ, like if you're coming from Godot and it's like, I don't want another tool and I'm not going to use Java and all that, it's okay. You just unzip this thing, go to Godot exports and libGDX exports, and here are the HTML directories, and I have a batch file called server batch, and I'm going to show you how to do that. And you could run a server locally. Oh, and again, it's just Windows, right? Again, I'm not going to put more effort into this because, again, for me, I'm already sold. It's like there's no way I'm going to ever go back to libGDX. It's just a complete waste of time. I'm sorry to be harsh, but it's true. But anyways, okay. So in terms of the libGDX is, if you do dir, here's the jar file, which means you could run this jar on Linux, Windows, Mac, right? So, and you could pass the number of threads to this. So all you have to do is make sure you install Java 21 or something. They just make sure it's a modern version of a recent version of Java. That's jar and the jar file, and then pass it the number of threads. By default, it's 11, but you should not take the default because you might only have an 8-thread CPU. And you take the number of threads of your CPU and you subtract 1. And the reason why you want to do that is you want to have 1 thread available for the JVM to do its stuff. And so if I type in 7, I'm only going to use 7. And as you can see, it quickly, here, I'll exit out here. It actually set up the number of threads to 7. So I'm going to do that again. Let's just clear java.jar, jolt benchmark, blah, 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 .jar, and then 7 or 5, or if you have like 32 cores, you could do whatever you want. But anyways, do whatever thread that gives you the best performance in libGDX. I tried all of them, and what I'm noticing is if I go from 11 to 10 to 9, my FPS goes down only a few FPS, which means the threads are not really doing that much additional benefit, which means there's got to be some other bottleneck and all that. Okay, so how do you run the HTML? Go into HTML, and if you have Python installed, you just type in server, and you go like this, and your default web browser comes up and it runs it. Okay. And to get the results after 5 iterations, go to more tools and developer tools, and that's basically it. But you don't really even need that. I mean, you could just see it's slower, right? You just, whatever. Now, what happens if you don't have Python and you don't want to install Python? I'll tell you what to do is you could go to IntelliJ, right? And let's run the Godot one. And is you go to the index file, and you have to use IntelliJ because it has a built-in web browser. I mean, web server. And you go open in browser and go to default, or just if you have Chrome, just whatever, but just use default. And as you can see, things are really nice here because it's Godot, right? So because it's using SIMD on its web builds and stuff. So that's how you have multiple ways of running the web, right? Because the web one is more interesting. The desktop is 70% faster on Godot, which is very good, but the web is just, I mean, if you're going web, then I mean, don't use libGDX. I mean, GWT is even worse. So, so let's stop this. How do I run the Godot one? I'll show you. Godot exports, type in dir. Make sure you could just double click this one, the console. Make sure if you have Windows, you don't have to even be in, but if you don't type in this one, you won't get a console and you won't get the results. Now, if you don't want the results and you just want to see and just ballpark it, then you could just run the exe file, right? But just run that. And here's the desktop version. Pretty easy stuff. You don't have to pass the Godot version threads. Believe it or not, you don't have control over threads. The only thing you have control over is you can specify to the engine that you want to run Jolt physics on a separate thread. Now, because it's running under a separate thread, it has access to create even more threads, to worker pools, to do additional work. You don't have access to that. However, there is a proposal, like someone said, I think it was Xylan who created H-Terrain or M-Terrain, I forgot which, but he's well known doing cool stuff. And because he's doing a terrain generation and all that kind of stuff, he wants to have control over the number of threads that are using for terrain, and he wants to just assign a sub number of threads to, and it's been denied, not planned. That being said, is maybe in the future they'll change, but it kind of really doesn't matter, because again, I'm showing you it performs better than libGDX, where you have control over the threads, right? So, anyways, it's interesting. I like the debates that happen with Godot, and you don't have to agree with them, but at least it happens, right? And you have access to the contributors, and you can have a conversation with them and say, I need control over the threads and this and that and all that kind of stuff. So it's really, really cool. Yeah. So the other way to run the libGDX is you can just use the Gradle and just run. You could run the TVM here, or you could just run the desktop here. You have to know about libGDX and Gradle and all that kind of stuff to do this. But this is just on the libGDX side to run the libGDX. And the source code is available. If you see a mistake, let me know and I'll rerun the test. Either way, I don't see it doing better on the web than Godot and stuff. So, yeah. Here is the Godot project over here. I am not releasing this code. And the reason why is if I give this to a libGDX person, they're just going to run this project like this. And when they run it through the editor, it's in debug mode. Even if they run it on the web in a browser, that's also debug mode. And that's not a fair comparison, because release builds could be up to 40% faster and all that kind of stuff and everything. 20 to 40%. It doesn't matter. It's just that's the reason why. And if you see the code here, it's not really that much. It's 126 lines, and let's go to Java. And how many? 440. But anyways, I tried to minimize the change to the original test. Right? So one of the things XPE was doing wrong, he was calling this optimized broad phase after he deleted all the body, the reset of all the bodies here, right? He did it here. Why would you want to optimize after you removed all the bodies? But anyways, I did that, and I implemented physics ticks somewhere. Again, I did this last month. Yeah. Step physics, yeah, over here. Here it is. Since libGDX, look here, I'll let you read this. Oh, you can't change the font here, eh? What? Since libGDX is an incomplete framework for 3D, it does not have any sense of physics ticks or physics process like render flow, and I have to create my own. Target 60 frames per second. Yeah, that's a good comment. This is basically, I'm targeting 60 updates to physics and stuff, or else Honestly, it would even be worse, right? And this again, like I did my best to make libGDX as fast as possible. Yeah. Okay, so I think that's it. I think I bored enough of you guys and ladies with this stuff, and I will include this PDF is important. I will include this because it has a lot of information on everything, and please read it before making comments like, oh, maybe you didn't do this, maybe you didn't do that, or what about that, and all that kind of stuff, right? And yeah, I tried to be as transparent as possible of all the stuff that I did and all that kind of stuff. But anyways, one good thing about Game Jolt for libGDX is now there's at least another physics engine for the web for libGDX, which is good, even though it's slow as it's very slow. At least there is one. Okay. Anyways, so I'm out. Oh, by the way, my next video is going to be how I improved my libGDX 2D game. It's a remake of Raid on Bungling Bay, Will Wright's 1984 Commodore 64 game. And I worked on it for a couple years part-time using libGDX. And now it looks way better and it performs 2.5 times faster. So I have a whole series on why you shouldn't make 3D games using libGDX because it's an incomplete framework, and I have 2 hours of content on that. By the way, this Jolt physics engine performance test basically adds on top of that why you shouldn't use it because its physics is slow. But now I have a 2D example coming up where I don't know, like it's just 2D, and like there's people working on games in libGDX for 10 years and they're having performance issues, and I want them to actually watch it and say, look, I have a simple game and it's twice as fast. Like, can you imagine? Like, yeah. Okay, I'm out. Thanks for watching. If you're still watching, take care. Bye.